Welcome pre-cal students to the homework help video page, and that is not the right page, so hold on 1 second and we'll fix that. Page 400, and if I can get this thing to work, my goodness, page 464, numbers, and there we go. Okay, so welcome to the homework help video. That's a little bit better, and let's see if we can move this out, and here we go. Okay, number 67. Now on number 67, they want us to complete the table for compoundings per year for one compounding per year, and then 2 per year, and then 4 per year, and then 12 per year, and then 365 per year, and then continuous compounding. Okay, so here we go. Let's go ahead and do this. First of all, we want to find out the balance, how much money we'll have after we have left the money in the bank for 10 years, with it being compounded once every year. So here's the formula. Now for the P, I'm going to substitute 2,500 for R. I'm going to put 0.08 for N. That's how many times the money is compounded per year, and it's being compounded one time per year, so put a 1 here, and then NT, so 1. The T would be 10 for 10 years because of this right here. Okay, so students, it really does become a calculator problem, and my advice to you would be to type this into your calculator first. So 2,500, 1.08, and then multiply these two numbers together here and get 10. And then go ahead and type all of this into your calculator at the end here, and you should get this right here. You should get $5,397 and 31 cents. Okay, so there we go. Now, I'm not going to do all of these for you over and over, obviously, but I will fill each one in for you. So here's what I mean by that, okay? The next thing they want us to do is find the balance of your money after you've left it in the bank for 10 years, with it being compounded 2 times every year, so twice a year. So this 1 right here would become a 2, and this 1 right here would become a 2. And other than that, students, nothing else would change, okay? So if you type all of this into your calculator the appropriate way, you should come up with $5,477 and 81 cents. Okay, there we go. Now next, they want us to find the balance when we have the money being compounded 4 times in a year. So now your N will be a 4. So make sure you have a 4 here and a 4 here, and if you type all of that into your calculator correctly, you will come up with 5,520 and 10 cents. Okay, so moving right along. Now they want us to find the balance when you've left your money in the bank for 10 years, but the interest is being found or compounded 12 times during a year, or in other words, every month. So now we're going to use 12 for N. Okay, so here we go. So we put a 12 here, and we put a 12 here. Okay, and if you type all of that into your calculator correctly, you will come up with $5,549.10 again. Okay, now we're going to say that the interest is being found every day. In other words, 365 days in a year. Okay, so now the interest is being found every day. So now all that's going to happen is your 12 here, your n is going to become a 365. So let's get a little more space here. There we go. And we'll put 365 right here. And right here we'll put 365 and then a 10. And if you type all of this into your calculator correctly, you will come up with $5,563.36. Okay? So there we go. So all of these here, we use the same formula because it was a number of compoundings of interest so many times during a year. Okay, now lastly, they want us to find the balance when it's compounding continuously. And of course, that's going to be a totally different formula. And here is that formula. A equals P e to the RT power. So for my P, I'm going to put 2500. That's my principal. And of course, E will remain E. My rate will be 0.08. And my time, my T, will be 10. And students, once again, this is just a big calculator problem. I mean, just take 2500 times e to this power right here, and you should get this out. You should get $5,563, so very similar to this right here, and 85 cents. So there we go. Okay, so I hope this makes sense. All right, students. Okay, moving on. Number 85. On the day of a child's birth, a deposit of $25,000 is made into a trust fund that earns 8.75% interest, compounded continuously. Determine the balance in his account on the child's 25th birthday. Okay, well, notice here we're dealing with compounding continuously. So the formula will be this right here. Okay, so where the A is, or where the P is, I will put 25,000. For the R, I will put 0.0875 times T. Now T is 25 because it says we're going to leave the money in until the child's 25th birthday. So that would be for 25 years, okay? So, with your calculator, if you were to type this whole expression in, you should get this right here. This would be a really nice 25-year-old birthday present, wouldn't it, students? $222,822. And there we go. Okay? All right. Continuing on. Number 87. Now, this one here, we're not going to do everything they ask us to do. This is a really simple problem. And it reads as follows. There are two options for investing $500. Okay, the first option is 7% compounded every year, annually. The second option is simple interest. And you should remember the simple interest formula from middle school. I equals PRT. And so it says here, identify which graph in the figure represents each type of investment. Explain your reasoning. Well, students, hopefully you understand this. Simple interest is not the best way to make money. Okay, it's going to be pretty much a straight line. Okay, a linear relationship like this. Okay. So notice the money is not going to increase as quickly, but compounded annually, that's exponential. Okay, so it's going to have a curve to it. So it's going to increase quicker and get more money quicker. Okay, so when it says identify which graph represents each type of investment, this black line here that's taking off like this, that's going to be the compounded annually. Okay, and the straight line here is going to be your simple interest. Now, I'm not quite sure why they say this. They ask you in part B to verify your answer by finding the equations that model the investment growth and then graph the models. We're not going to do that. They've already graphed it for you right here. Okay? So there's no need to do that again. I'm kind of confused why they would ask you to do that. And then secondly, when they say find the equations, well, we already know what the equations are. They're this. This one here would be simple interest, and this one here would be the compounded so many times during a year model. So I'm not going to worry too much about writing those up for part B, okay? But the main thing I wanted you to see is simple interest is a linear relationship, okay? And it's going to increase very slowly compared to an exponential function, which is going to take off a lot quicker, okay? Like this. Okay, moving on to number 89. Now, inflation. The annual rate of inflation averages 4% over the next 10 years. The approximate cost of goods or services during any year in that decade will be modeled by this model right here. Okay, where T is the time in years and P is the present cost. So if the price of an oil change at the present is $23.95, estimate the price that the oil change will be 10 years from now. So here's our model. Now C of T, right here, students, C of T simply means cost based on time. In other words, as time changes, the cost will also change. So C of T equals P. Now that's your starting amount. So it says here the present amount for an oil change is $23.95. So I'm going to put that for my P. Okay? And then obviously for T right here, I'm going to put 10. So now with my calculator, if I type all of this into my calculator, I will come up with 35. I'm going to put C of 10. That means the cost based on 10 years from now would be $35.45. Okay, so there we go. It's the cost based on 10 years from now. So there we go. Moving on to number 91. A certain type of bacteria increases according to this model right here. Now, T is time in hours. Find the following. So here's what they want us to do. They want us to put 0 in for T, first of all. So 100 e to the 0.2197 times 0. Okay? Well, students, if you type that whole thing into your calculator, you will come up with P of 0 equals 100. Now next, they want us to simply just put in a 5 for your T, P of 5. So here we're going to put a 5, and then type all of that into my calculator. If you do that correctly, you'll come up with P of 5 equals approximately 300. Okay? Then they want us to put in 10 for P. So, there we go. So P of 10 would be 900. Okay? So there we go. Just simply taking an exponential function and learning how to substitute numbers into the function and get out an output. Put numbers in for your input and then get out numbers for your output. Okay, moving on to number 93. Okay, here we go. We have Q represents a mass of radioactive radium whose half-life is this many years. So in other words, it takes 1,599 years for whatever amount of radium you have to shrink down to half of its original amount. Now the quantity of radium present after T years is given by this formula here. Determine the initial quantity. Now remember, the initial quantity means when T is 0. So if you put 0 in for T here, 0 over 1,599 is 0. 1/2 to the 0 power is 1. So you have 25 times 1. And of course, 25 times 1 is just 25. So the initial amount is 25, okay? Now moving on to letter B. Determine the quantity present after 1,000 years. Okay, so we're going to put 1,000 in right here for T. Okay, students, so for part B here, I'm going to put 1,000 in for T. So right here, where my T is, I'm going to put 1,000. Okay, so we have 1,000 divided by 1,599, and then whatever I get here, take 1/2 to that power, and then hit equals, and then times 25, and you should come up with approximately 16.21. Okay, very good. Now let's take a look at letter C. This is very interesting. Okay, letter C. Okay, students, now in letter C it says this: use the graphing utility to graph the function over the interval T equals 0 to T equals 500. Now this is pretty simple to do, okay, but you're going to use the graphing calculator, and you're going to have to set up your window, okay? Now students, look, on your calculator, we know that usually the variable by itself is your y, so we're going to call Q our y, okay, for our graphing calculators. And we're going to call T our x, okay? So there we go. Now, first of all, let's fix our windows. We know that we want our x's to run from 0 to 5,000. Okay? So listen carefully, please, students. Go to your top buttons. Second one from the right at the top says window. Push your window button. And then it says X min X max. Well, we know right here we want our x's to run from 0 to 5,000. So I'm going to go ahead and put 0 for my x min, and for my max, I'm going to put 5,000. Okay? That's pretty simple. Now, watch carefully what I do next. I already know that when I put 0 in for x or for t, I got out what? Remember, we did it here for letter A. We got out 25 right here. Okay? And then, if I were to put 5,000 in for t or for x, what would I get out? Well, I've already done it for you to save you some time. But what you're going to get out is this. You're going to get 2.86. So guys, look. That means you want your y window to run from 2.86 to 25. So go back to your window button, scroll down to y min, and for y min put 2.86. I'm just going to put 2, the whole number 2. And then for your y max, I would put 25. Okay, now we have to enter the equation. So go to y equals, right here, y equals, where you type your equations into your grapher to graph them. Okay, and I would type in your grapher 25, then a parentheses, then hit 0.5, then close your parentheses, then your arrow button, and then parentheses, and then x, because we really can't use a t, so x divided by 1599. And then hit the graph button, and you should see a pretty good exponential graph that looks like this. Here's your window on your calculator. And you should have the axis coming down this way, and the other axis coming off this way. And the graph should look something like this. Starting here and coming down like this. And there you did it, okay? You graphed it over this window right here from 0 to 5,000. Okay? Pretty cool. Okay, number 95. Or number 97, excuse me. Okay, the population of Las Vegas, Nevada for selected years from 1970 to 2000 can be modeled by this model right here, where t equals 0 corresponds to 1970. Use the graphing utility to graph the model. Okay? Now, here's what we're going to do. We're going to say 1970 is our starting point. So t equals what? 0. And since we're in the year, 2014, that would be 44 years. So I'm just going to say we'll go and figure for the 2015. So I'm going to graph this function from 1970 to 2015, okay? So t would equal 45. Okay, so there's my window. There's my window right there. So I go to my window button on my grapher, top, all the way to the top of your grapher, second button from the left, and it says window. Push window, and I would make your X minimum 0 and your X maximum 45. There we go. Now, if you put 0 into this equation right here, trust me, here's what you're going to get out. You're going to get out this right here. 115.5. So we have an ordered pair 0, comma 115.5. And then if you put 45 into your function up here, trust me, you will get out 855.6. Okay, so we have an ordered pair right here, 45, comma 855.6. So now we have our window for our y values right here. So go back to your window button, scroll down to your X minimum, and put 115.5, and then your Y maximum would be 855.6. And then go to your Y equals and type this in. Okay? And after you've typed it in, hit graph, and you're going to get a really good graph of this equation. Okay? So here's what it would look like, something like this. Here's your window on your calculator, and you have a coordinate plane going this way. I mean, an axis going this way, and an axis going this way, and the graph looks like this. If you did it correctly, it looks something like this. Okay, there we go. Now let's take a look at part B and part C here real quick. Okay, part B says find the population for the years 1970, 80, 90, and 2000. Okay, we'll do that real quick here, guys. Shouldn't be too difficult to do. So if we, hold on one second here, students. We already know the population for 1970 would be 115.5, and it says in thousands right here. So move the decimal 3 places, so 1, 2, 3. So it'll be 115.5, be 115,500. Okay. For 1980, we would put 10 into the function. If you did that correctly, you would get, hold on one second, 180, 236,000. So 180, comma 236,000, rounded, of course. And then let's see, 1990 would be, we would put 20 in, 281,257. And then for 2000, we would put 30 in. So very quickly we'll put 30 in. And we would get out 438,899. Now, students, they want us to estimate when the population will exceed 750,000. So, with my graphing calculator, I'm going to start scrolling down, okay, looking for when. I'm going to go to my table, and I'm going to start scrolling down past 30, In your table of values, you should see on the right on the right side the Y values are increasing pretty quickly. So here we go. Yeah, pretty quickly. So it looks like now here's my graphing calculator says, okay? My calculator says that 42 gives me out 748,650. Okay, no, I think they want to know the year that it goes past 750,000. Yeah. So let's go to 43. 43 gives me out 782,000. 720. So it looks like we're starting in 1970 and we're going to go 42 years past that. No, 43 years past that. So in the year 2013, they're estimating the population of Nevada, Las Vegas, Nevada, will exceed 750,000. Okay. All right, moving on to number 9101. Okay, again, we're just putting numbers in and getting numbers out. Pretty simple, okay? So I will not spend a lot of time doing this. But here we go. T equals 0 corresponds to 1970. Letter A, they want us to find the death rates in these years. So for 1970, put a 0 in, and you will get out 495,060. Now, I think they made a mistake here, a typo. In the problem, I think it should say per 1,000 people. Because if it's 100,000, then it's going to be like the decimal was here. And you'll see that, students, when you put 0 in and do all the work, you're going to get out 495.060. So if it's 100,000, then you should move the decimal like 6 places. In the back of the book has this for the answer. So I'm pretty sure they meant to say per 1,000 people. I could be wrong, but I think that's right. But moving on, the death rate in 1980, well, put a 10 in for your T, do all of the work, and you should get 405,420. Okay? Okay, moving on to 1990, put a 20 in. For your T, and you will get out 327,650. Okay? And then for the year 2000, you will want to put 30 in for T, and you will get out 260,170. Okay? Now, so there's the death rates that's going to be caused by heart disease. And you can see how it's decreased a lot, probably by medicine and also people being more aware of how to take care of their bodies and stuff like that. Now, part B says, do you think this model could be used to predict a death rate for the year 2010? Well, students, what I did is I went ahead and put 40 in for T, which would give me out the death rate for 2010 according to this model right here. And I got out 201,627. Now, for me, I think that yes, that's a pretty good prediction because I can see how the number is shrinking Now, eventually, this model would not work because we're never going to get the death rate from heart disease down to zero, obviously. But personally, yes, I think that you could use this model to predict the death rate for 2010. But eventually, you could not use this model because it would eventually get down to zero, and there's no way that we would ever get the heart disease deaths down to zero per year. Okay? Students, that's it. I hope this homework help video has been a help to you. If you have any questions, don't hesitate to call or email.